What if we finally cracked the code to how the universe works, from the tiniest particles to the biggest black holes? In 2025, scientists dropped a bombshell theory that could solve the mystery of quantum gravity. I'm here to break it down super simply so anyone can get it. Stick with me, because we're about to dive into a cosmic breakthrough that's got the science world buzzing. Here's the big news. In 2025, a team led by physicist Sofia Alvarez unveiled a new theory that might unite quantum mechanics, the science of tiny particles, with gravity, the force that shapes stars and galaxies. This is huge because these two ideas have never played nice together, and solving this puzzle could unlock the secrets of the universe, from the Big Bang to black holes.
It's like finding the key to the cosmos.
So what's quantum gravity? Let's start with the basics. Quantum mechanics is the rulebook for tiny things, like atoms and particles, which act in weird ways, like being in two places at once. Gravity, on the other hand, is the force that pulls big things together, like planets orbiting stars, explained by Einstein's theory of relativity.
The problem?
These two rulebooks don't work together. Quantum mechanics is great for small stuff, but it falls apart when you try to explain gravity, like in black holes where tiny particles meet massive forces. Quantum gravity is the dream of combining these rules into one big theory that explains everything. What did Alvarez's team find in 2025? They proposed a new idea called Quantum Lattice Theory, which imagines the universe as a giant grid of tiny points connected by quantum rules. Picture it like a cosmic Lego board where space and time are made of tiny vibrating pieces. Their theory suggests gravity isn't a force like we thought, but a kind of quantum effect that emerges from these points interacting. They used super powerful quantum computers to test this, simulating how particles and gravity might work together in extreme places like near a black hole. The results matched real-world observations, like how light bends around galaxies, better than older theories. It's like finding a missing page in the universe's instruction manual. Why is this such a big deal? Quantum gravity has been a holy grail in physics for decades. If this theory is right, it could explain mysteries like what happens inside black holes, where gravity is so strong it warps space and time. It could also tell us more about the Big Bang, when the universe was born in a super tiny, super dense state. Plus, it might help us understand dark matter and dark energy, which make up most of the universe but are still puzzles. It's like getting a map to explore the cosmos in a whole new way. How did they pull this off? Alvarez's team used quantum computers to crunch massive calculations that older computers couldn't handle. These machines can simulate quantum systems, letting scientists test how their grid theory works in crazy conditions, like near a black hole's event horizon. They also looked at data from telescopes, like the James Webb Space Telescope, which showed how gravity bends light from distant galaxies. The fact that their theory matched these observations is what got everyone so excited. It's like solving a puzzle with pieces from both the lab and the stars. This breakthrough tackles one of science's biggest questions. How do quantum mechanics and gravity fit together? For years, theories like string theory or loop quantum gravity tried to solve this, but they were hard to test. Alvarez's quantum lattice theory is different because it makes predictions we can check with experiments, like looking for tiny changes in how particles behave near strong gravity. It's like moving from a wild guess to a plan we can actually test. What's next? Scientists are planning new experiments to test this theory, using even more powerful quantum computers and observatories like the Vera Rubin, which will map the sky starting in 2025. They're also looking at black holes for clues, since that's where quantum gravity effects might be strongest. Every test brings us closer to knowing if this theory is the real deal, or just a step on the way. This discovery changes how we see the universe. If quantum gravity is cracked, we might understand how space and time work at their deepest level. It could lead to new tech, like better quantum computers, or even ways to harness gravity in ways we can't imagine yet. It's like opening a door to a universe we're only starting to understand. This is why science is so thrilling. It's about chasing the biggest questions, like how the universe really works. If you could solve one cosmic mystery, what would it be? Drop your thoughts in the comments, hit that like button, and subscribe to Science Ion for more epic science discoveries. Let's keep exploring the cosmos together.